today we're going to talk about, what do they call it? I think in the book they call it reproductive strategies. It's the perfect, let's face it, it's the perfect Valentine's Day topic, is it not? There's, Phyllis, I conned Phyllis into teaching ecology one time up at College of St. Mary's. And she used the same book, and I asked her how she handled these. And she said, I just went through them the same way. And I said, yeah, but it's a mess. They're talking about reproductive strategies before they ever talk about population growth. That doesn't seem to make sense to me. Plus, it interferes with the understanding of sexual selection, which isn't really part of this. I said, I just don't like where they put it, but I understand why they did it, because it really is part of life history strategies, so they're trying to make a point. Kelly, thank you so much, and I'm already dry. Now, if I just can remember not to collapse this while there's water, we'll be all set. Not so good for you guys in the front. It'd be like being at a Gallagher show, except that you even know who Gallagher is. That's the guy who had the Slam-O-Matic, and he would smash watermelons and anything people in the audience. It's back when comedy was so pure and highbrow. I never saw Gallagher, but I watched the special on TV. Okay, so that's the reason. So I'm going to apologize up front. Not everything fits here, but that's okay. If you hear things multiple times, that's helpful for memory, right? So, there's about a million ways I can go on this lecture. I could talk to you about the evolution of sex. I can talk to you about these selection strategies, but let me start at the end rather than the beginning. Number of offspring. If we look at this offspring business from an evolutionary standpoint, there's really three things. We know that for evolutionary success, you have to have reproduction. Presumably you have to have reproduction because, as I argue, the weight of mutations on cells, particularly through UV, but also through background radiation from the Earth, will inevitably scramble your DNA enough that you'll die. I learned, thanks to one of your colleagues, that this apparently is not true for hydras. And there's a question, you know what a hydra is? Tiny little multicellular thing. Apparently hydras routinely shed all their cells so that a hydra is perpetually young, and there's some question about whether hydras ever die in the way another organism does. And forever. They have no lifespan. They'll live until something eats them or something happens in an abiotic way, because they're constantly producing new cells. It's also the reason you can cut them in two and grow two or more hydras. Now that said, you can kill them. It's not that they won't die. What we're really saying is they don't die of old age. Freaky, weird man. And if it works, then why didn't the rest of us use the same trick? I know the answer to that question. It has to be because of differentiation. You know what I mean by differentiation? Differentiation is when cells become fingernails, or certain cells become thumbs, or what have you. In hydras, essentially, apparently all the cells are sort of embryonic in that they don't take on a specialty. So that's got to be part of the reason there's that trick. And it's definitely true that cellular differentiation is a huge advantage. That's why we're here. That's why we see the organisms we see. So my guess would be that you can't pull the constantly replace all your cells trick with organisms that have different tissue types. So it's great if you're willing to stay forever young, so to speak, but not so great if you actually want to, I don't know, drive a car or something cool. So, all right, so that's an endpoint. We got to reproduce. Evolution really does not operate, constant emphasis on the survival of the fittest. That's not really it. There's three things, in my opinion. Yeah, you do have to survive. So you have to live long enough to reproduce. That's the thing you know about survival of the fittest. You've got to have somebody want to mate with you, whatever that means in the context. Want, in a vague sense. In other words, I call that survival of the sexiest. It doesn't matter if you live if you don't reproduce. And if you're a sexual species, that means that somebody wants to do the nasty with you. And then the third thing is you got to get pregnant. I mean, it's not enough to just be having sex. You got to have some offspring. And so that also is a point for selection. The fact that, yeah, I fool around all the time and yet I don't have any. That's no good evolutionarily. You've got to produce. And if I'm honest, there's sort of a fourth one. It's not enough to produce the kids.
So I guess in reality, I still think of it as three, but maybe it's four now, right? So this business of reproduction, what is it you reproduce? Do I reproduce one? Do I reproduce many? Do I give up my life to protect them, or do I just kick them out of the house and say, get going? What are the things that I do? And more than that, what can I do? What is it possible to do? Cameron and Liz want to buy a house. They're really frantic about this house thing. And they don't make enough money. I guess it makes sense that they could make a house payment. But am I a failure as a parent because I don't have the money to give them right now for a house payment? I don't know. But I do know this. If evolutionarily, Cameron's my son. If Cameron's reproductive success depended on whether or not he had a house, then I am an evolutionary loser if I don't do whatever it takes to get him a house. Simple as that. So there will be pressures, and those pressures will differ depending on your species. Here are the general statements that I will make. For small organisms, it doesn't take a lot of material for them to grow. They grow rapidly. They don't take a lot of resources. So it's not surprising that small organisms produce a ton of offspring. So if you want to say it's a strategy, there's an observation that small organisms produce a ton of offsprings. And by extension, the reverse is also true. Very large organisms tend not to produce many offspring. Because it takes too long to gather the energy and so forth. So in an absolute sense, not a good sentence, if we look at limits on reproduction, we can make the observation that there is always an energy limit on reproduction. That's what I want to say. How much we can reproduce depends on how much energy we can accumulate and then devote to our kids. It's also true that sometimes there are other constraints. It's not just energy. It's not just, money to pay the builder, but it's also building supplies. So here's a good question for you. What's the biggest building supply barrier for producing offspring? What is the unique thing that all living offspring tend to need that organisms often have difficulty accumulating?
Is it food?
It's a specific type of food. You're on the right track. The answer lies, for those of you who are from out of the state of Nebraska, at Ole's Steakhouse in western Nebraska. Protein, 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 protein. Lots of organisms are protein limited. And so, getting protein becomes a big deal. Those of you with black ancestry, no, I should back off. It should be all of us, because we all have African ancestry. But those more recent, we can be certain that at some time all of us were exposed, our ancestors were exposed to selection pressure from malaria. Right? And mosquitoes are mosquitoes are the best organism on the planet for transmission of disease. And more than any other organism, they remain the most dangerous animal to man, and historically they've been the most significant animal man's ever had a relationship with. Why do mosquitoes feed on you when none of their relatives are blood feeding? Mosquitoes are most closely related to a bunch of midges that just feed on plant juices and so forth. So what's the story? Yeah. The story is somebody had an adjustment in a behavior. Lots of plant feeders will sometimes try to feed on an animal because they're stupid, only it's not always stupid. And in the case of mosquitoes, they apparently had enough flexibility in their feeding behaviors that somebody fed on blood. Well, so what? That's not going to get them anywhere. But then they had the other mutation that lets them start processing the blood and extracting protein. And a whole bunch of things like detecting CO2 plumes, like looking for having the ability to detect infrared radiation so they can tell where the surface blood is on their prey. It's not by chance you get bit by the ear or these places. It's because mosquitoes see you like the predator in the Predator movies. They come in and they look for surface blood because there's more capillaries there. They evolved the ability to give you an anesthetic. The reason your bug bites itch is because mosquitoes don't want you to feel pain. Why? Because then it gives them time to finish their blood meal. That's also, interestingly, the reason why horsefly bites hurt like hell, because they don't care. When they're on the back of a horse, the horse can't get them off, so tough. They just, and in fact, I love doing this. Their mouth parts are little swords, and what they literally do is jab, 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 till there's a pool of blood. Then they stick their spongy mouth parts in and soak it up. Oh, it's starting to clot. Let me jab, jab, jab some more, so I can cause you some more pain. And they do that because the herbivores they feed on really don't have any defense against it. So there's protein limitations. So that tells us that, depending on the species and its circumstances, the number of young aren't just a function of what it would like or whatever, but there are certain constraints. Access to protein is a big one. And as I mentioned in an earlier lab, it's ironic, right? We got nothing but nitrogen here in the atmosphere, and yet one of our biggest limitations proteins, have babies, create eggs, all that jazz. And in the process, we're poisoning ourselves, so then we have to have some way to get the stuff out. I give the cat subcutaneous fluids every friggin' day, and they spend the rest of the day changing his diapers. If you want to know about cat diapers, I'm your man. Because he's processing all that fluid. What the hell? It's just, put it in, I take it out. Put it in, I take it out. Put it in, I take it out. But by God, he's alive. So there's that. Setting those limitations aside, what can we say? Under what circumstances would there be advantages and disadvantages to have a lot of offspring or to have a few offspring? I can give you these, and I will, but pause for a moment and just think about it. This is, we have to ask our past lives. I stole your pen, and you need it for your notes. Particularly fancy pen, ballpoint pen. Costs next to nothing to produce. They had the machine, the brass, and it's even got a funky fill in there that's one of those rollers. What's the difference? They both right. What's the difference in those two pens? Yeah. The quality. So can I justify to Phyllis, because that's, trust me, that's who I justify to, spending the $29 on this pen versus 2 cents for the ballpoint. Well, I tried and failed, gentlemen. So for those of you who think your logic abilities are so great that your romantic interest is going to be persuaded by your argumentation skills, good luck with that, ladies. So not so much. But it is a quality issue. In terms of evolution, what does quality mean? Does it mean lifespan? Does it mean how many offspring you produce? What does it mean?
Make it easier to specialize.
It could mean that. But here's what we can say in a generic way. You know those 3 things I said that lead species where selection acts? It's that quality is making you get through those 3 hoops. That's what quality is. You survive, you get a mate, you reproduce. And here's the interesting thing. I can have, let's say I have $29. I can buy one $29 pen, or I can buy 290, well, let's be honest, 2,900 of these little pens. Which is a better strategy so I'm able to survive? In some arenas, the world is so harsh on pens, even 2,900 pens aren't enough, and you'll never be able to finish writing with them. In some arenas, the pressure from disease and predators is so great that unless you are very high quality, you are out. You're going to die. Right down to the last man.
Just have to make all your shapes somehow.
But you only need to have a couple pens survive. So the interesting situation is, I could be in a situation where most of my offspring die. 99% of them die. Hey, that's okay, I got my replacement. I'm good to go. Now, the math doesn't necessarily work out quite that way when we try to look at it, but it's not far off. So, to give you an example, the difference between a population explosion of an insect and normal might be as little as 1 or 2% in the predation rate. Which seems crazy, right? I mean, what, you have one guy take an extra bite and all of a sudden you tell me I got grasshoppers up to my waist? That doesn't seem to make sense. It's because that it interacts with a huge reproductive rate. One of the troubles we have as biologists is how we're trained. If you're trained with vertebrates or with birds as a specific group, well, birds are an example. What are the range of reproductive rates in birds? They're not very large. In my world, they're huge. There are insect species that produce 1 offspring, and there's insect species that might produce 40 or 60,000 offspring. So, answer to test questions, answers for how to think about this. The forces that derive what led a species produce the number of offspring it has are the pressures from the environment. And we tend to think that, oh, a certain species is going to evolve to have a large number of offspring, so that means as it goes through evolutionary pressure, they'll continue to do that. That's not the case, because the world's dynamic. It's not true that we have one set of animals that have high reproductive rates and one set that have low. We find there's a mixture in there. And the reason there's a mixture is because of how dynamic environments are. Here's the next big thing that follows from that. It is a big honking waste of time to have sex. You run risks of being killed, you have run risks of being rejected, it costs a ton of energy, versus, hell, just, clone myself, man. The reason for sex is the same thing. on a world that was completely stable, I think there'd be little evolution, to be honest with you. Let's assume, this has been speculated for years. You know that, I guess you know this, you know that the reason the Earth's core is molten is because of radioactivity? And so, after the Earth formed and after we had the collision that led to the formation of the moon and those things coalesced, we remain seismically active because there's a lot of reproductive, radioactive minerals, elements still in the core. They're heating up, they're still heating up the iron. But there will be a time, and I think it's 2 billion years, when we anticipate the core will start cooling. Not to worry, the sun is going to be expanding and will consume the Earth before then. So you don't have to worry about death by cold Earth. We'll have death by solar expansion, from what I read. Anyway, we can envision a world very easily that is slightly different in size, had some different sequence of events where life starts evolving, but then the volcanoes stop. It's in a stable orbit. What are the forces then that would drive additional evolution on that planet? Very few. And so what would you expect? I would expect to see that all those species, that sex would be abandoned, all the species would be asexual. There's nothing magic about sex. And so if what I said is true, that species can become sexual and become asexual back and forth, are there examples where this happened? Of course there are. I wouldn't have brought it up and embarrassed myself. So we can see lineages that were sexual, and then they abandon sex, they're asexual, and we can see lineages where it comes back. Another reason why you should be working on insects, because if you want to study weird sex, that's the only group of organisms. Other than, there's some marine worms and so forth. I'll give them props. But for terrestrial organisms, nothing's as weird as insects. And so, are there species that actually have both types of reproduction in the same species? Yes, there are. And in fact, the existence of those species prove, as much as anything's going to prove, that what I told you is accurate. So let me give you that example. For almost all the aphids, so-called plant life, you know what aphids are, tiny green insects that form colonies or whatever, feeding on plants and what have you. No wings. They are the ultimate example of a species that wants to just produce as many individuals as quickly as possible. Why? Because the female gives live birth. We're not going to waste time waiting for eggs to hatch. And the daughters that she lays, which are clonal, are already pregnant. So the kids, when they come out of the mom, are pregnant, so that they're not wasting a lot of time. Well, the process, which you should know this term, that process is parthenogenesis. It's reproduction without sex. Are humans capable of parthenogenesis? Yes, we are. Unfortunately, not contradict Catholic and other Christian traditions, we would produce a female, not a male, by parthenogenesis. And I think it's one in every, I don't remember the statistic, but there's a fractional statistic of births that could potentially be parthenogenic in humans. And I don't remember the mechanism by which this occurs, but basically you have to have a doubling of the DNA. It's a mutation event. Okay, so these aphids are really active. And why do they do it? Because that means they can exploit resources that are transient. That means you can have an aphid land on one aphid land on a plant, and within a matter of a week, it can be completely occupied by aphids sucking its juice out. And, as you might expect, they might kill the plant. Well, that's an evolutionary dead end, right? I am not going to even begin to try to explain the genetics of this because I don't understand it. I just know the genes are there and that they are turned on and off. But grandma sees that things are starting to go to hell. Grandma, She produces a daughter who looks just like herself. Her daughter produces daughters that suddenly have wings. But as if that's not freaky weird enough, her daughters, her grandchildren, not only are granddaughters, but they're also grandsons. So in the switch to produce winged aphids that can move to other habitats, they also suddenly produce males, so there can be mixing of genes. Not so much males from this, but males from other aphid populations in the same species. That's where you'll be mixing. They disperse and go to other plants. So we have an example within a single species at a micro level that asexual reproduction, while things are fine, but the minute things start to go to hell, they switch to sexual reproduction. And they have other behaviors, and they have morphological modifications to allow them to move. So sex is about things going to hell. Sex is a response that life has to variability in the environment. And we can make an easy prediction that in systems that are highly variable, we would expect most species to be sexual. Why are there two sexes? I brought this up last time. It's not a function of the fact that DNA is double-stranded, you split it, and you have these two cells come together. Because those of you who are familiar with plants know that some plants have polyploidy. Actually, there's polyploidy in certain animals. Polyploidy, right? Multiple chromosome numbers, so you could have different numbers. So you could conceive of a species that had 4 sexes, right? Each contributes 1 chromosome, but the normal situation would be that they're quadruploid. Theory suggests that will never happen. Why? Because of gamete packaging. And so this is how it goes. And let me say right now, I am not telling you facts. I'm telling you informed speculation. What used to be theory, and I'm not going to pretend I know the latest on evolution of sexist theory, because it's still an active area of work. But to the best of my knowledge, this reflects what our current understanding is. It goes like this. You produce your gametes. That's relatively low cost. But you're going to have to package the gametes. And you're going to have to package them in such a way that they can meet another gamete and produce the actual organism that's your offspring. And just as there's this business about I can produce a lot or a little offspring, the same is true for gametes. I can produce a ton of gametes, but I give them no food. So when that cell forms, it's not going to have much to live on, and probably most of them are going to die. Or I could give it a huge amount of food, really have a high likelihood of success that it's going to survive. But then I can't do as many gametes. Few gametes are eggs, lots of gametes are sperm. It's as simple as that. There are apparently 2 stable strategies. One strategy is to produce a ton of gametes, the other is to produce a ton of eggs. Now let me enter dangerous ground, the sort of thing I'm not supposed to teach or I'm not supposed to say, but I'm going to do anyway because that's who I am. What are the implications when it comes to humans and other organisms? Differences in gamete number. Here's what you will often see. You'll read from many, many sources, and it's both right and wrong. Here's the general statement we can make. Because males have low investment in gametes, it would make evolutionary sense for them to have as many mating partners as possible and to spread their gametes far and wide. In contrast, it would make sense for females who have few gametes to make certain that they only mate with the highest quality males. Males wouldn't care about quality, they're all about volume. Females should care about quality because they don't have much to give. As a general statement, what I've just said appears to be true. When we look across particularly with animals, not so much with plants. So when we look at animals, we tend to see that, as I like to say, and other behaviors say, females are the choosy sex. Females choose who they mate with, and they evolved that way because they've got too high an investment in their gametes. Males typically are not the choosy sex because they have too low an investment in their gametes. But don't be fooled. You cannot use those rules for every species. And I've heard anthropologists make these statements for humans constantly, and humans absolutely do not fit that rule, despite what people say. So is it true that men are more likely, human males are more likely to commit adultery than human females? Yes, it is. Is that because they're genetically predisposed to do this versus females? Au contraire, mon frère. Why? Because it is impossible or rare for a human female, particularly during the evolutionary process, to successfully produce an offspring and get it to reproductive age. We are a species where pair bond formation occurred because it's the only way to get your kids to survive for reproductive age. Like other species, we have a requirement for parental care of young. And in any species that has parental care of young, the male has suddenly got eggs, right? Most males need to be there to help provide resources or protection or whatever. Otherwise, it doesn't matter how many females he mates with, none of them are going to survive successfully. There's a profound misconception about how mating works. It's the number of fertilizations that matter. It's the survival of the offspring. So, seeing as I've been giving you entomological examples, I want to leave you with what I think is the best example that illustrates this. There is, in the state of Utah in the western United States, a species of cricket called the Mormon cricket. It was involved with destruction of crops early in the settling of Utah by the Mormons, and they were saved by the seagulls who came and ate the crickets, and I believe there's a seagull statue someplace in Salt Lake City, which, if I'd been smart, I would have at least looked for when I was in Salt Lake City last summer and taken a picture of, because I would have got something out of that trip, but that's my, okay, but let's set that aside. I'm not bitter, not much. Mormon crickets are interesting. One, which in most species, which is bigger, male or female? And I'm not just talking about insects now, I'm talking generally. Gotta be female because she's got all those eggs, right? When do we see species where males are bigger? Generically, it cuts across things. There's a number of species where males are bigger than females. Why? If I just said under most species, the female's bigger. See? This is what I'm talking about. You're going to be able to answer that question. All you have to do is have the principles. Okay, so English said, yeah, it makes sense to me that females are bigger, so why would males be bigger? Do they have to be bigger to protect the female? Okay, that would be an argument. That's not really it. The real answer is the females are going to be bigger. Large males are a function of what's called sexual selection. That, and trying to figure out, forcing male, trying to identify which is the best male I'm going to let have my access to my gametes, you get all kinds of weird modifications. You get bird colors, brightly colored birds. What is that other than saying to predators, here I am, please come and eat me? And which species is the more brightly colored? Which sex is more brightly colored than birds? It's always the males, right? Because the females have, it's what happened is color then became a sign of genetic fitness, and so females use that. That's also the reason you have these weird-ass dances that birds do. If you can't complete this complex behavioral path, obviously you're not as selectively important. Okay, Mormon crickets. Females have a much easier way to judge the worth of a Mormon cricket because Mormon crickets have evolved themselves, Mormon cricket males kind of evolved themselves into kind of a really bad deal. Many organisms do not just spray their sperm around and do not even necessarily have direct sperm transfer. The ancestral condition for most species is indirect sperm transfer. One of the problems with indirect sperm transfer is the sperm it can easily dry out, and you're investing a lot in seminal fluid and that jazz to keep them alive. So people made what I like to call the sperm football. Organisms evolved things called spermatophores, which is the sperm football. I've heard it called the sperm curse, but obviously whoever invented that term doesn't understand the difference between male and female. It's a sperm football. In the case of male Mormon crickets, they got kind of carried away, and they make really big footballs. They basically make footballs that are so big, maybe they get to eat. Maybe they get to mate once. I mean, I don't know how they got this thing so backwards, but they've kind of lost the whole sense of what it means to be a male if you end up just keep making larger and larger sperm footballs. Here's why. The females made them do it. To mate, the male comes up to a female, badgers the hell out of her. Eventually, if she's even remotely receptive, and this is part of her testing him, she will let him climb on her back. And when he climbs on her back, she's weighing him. And if he doesn't weigh enough, she jumps and knocks him off, and she'll keep doing that. The females select the males by virtue of their ability to complete that sequence and to weigh enough. Okay? If they're allowed to mate, the female not only gets this big spermatophore, but she also gets all the semen that's in there, all the seminal fluids. And guess what's in the seminal fluids? Lots of proteins that the female can actually then digest to produce nitrogen and make even more eggs. What happens, though, when the climate goes to hell and it gets really dry and there's not much food to eat? The females don't have much food to eat. They're really starved for resources. Turns out that sperm football now might be the difference between producing eggs and not producing eggs. And under those dry conditions, the males never get on the female's back. The females get on the male's back. And the male weighs the female. And only the heaviest female is he willing to mate with. The way I explain this is the males became the limiting. About sexual selection, the easy answer to all sexual selection is this: the limiting sex chooses. Post-war Soviet Union. Post-war Soviet Union, okay? This is not just true of the Soviet Union, but this is a great example. If you want to hear a really beautiful literary example of this, and it's an easy read the book Cancer Ward by Alexander Solzhenitsyn, Nobel Prize for the author. But who was the choosy sex after the Second World War in the Soviet Union? The males were choosy. Why? So many males had died in the war. There was a hugely skewed sex ratio. And for females, it was an impossible situation. And in Cancer Ward, there's this beautiful scene where a young woman is about to have to go a radical mastectomy. And she's crying and pleading with one of the patients to have sex with her because she knows, one, she's never going to be married because she's going to be marred. And this might even be her only chance to have sex. Because the sex ratio is so skewed, there's no possibility anyone would ever select her as a mate, in ecological terms. This aspect will come back and forth too, because it turns out, it's not by chance that so many scientists want to look at sexual behavior. It's because it's a really fascinating insight into a lot of features of ecology. But I want to take you back before I turn you loose here. Remember what I said at the beginning? Interactions of individuals with the environment. These reproductive strategies are very much about that. So even our own existence as male and females are a reflection of how evolution deals with the problems of high variability in the environment and trying to cope with that. And so we represent, if you will, two extremes. an extreme where you protect a lot of resources where our ancestors, our ancestral worms, didn't. And now, when we come to our species, we're pretty much in the same boat. To get our kids through college and everything else, we're going to have to bring them back in the house at 27, and I gotta get enough money so I can get Cameron a house, so then they'll be happy and won't wait too long, so Liz can reproduce, and my genes will be carried on, and other people will have bad eyesight and genetic mental health problems, and all the other great features that I bring to the genetic mix. Okay? And with that, what else can I say but Happy Valentine's Day? I'll stick around if you have exam questions. Okay? Have a good day.